All right, today we're going to talk about problems on numbers. Okay, so in the last class we focused on geometry, right? All right, so we change the topics, All right, so the first problem I want to discuss is the following one. Right. So what is the sum of the 11th and the 44th digits? Okay, and that is digit is to the right of the decimal point in the decimal form. Okay. Okay. So given a fraction, a rational number have two representations. One is in fraction, other one is in decimal. But if it's in decimal representation, the decimal representation must be either was a terminating decimal terminating digits, or is repeating. Okay, so this is by definition rational number. Rational number, first of all, it can be expressed as a fraction. Okay, but if you want to write down the decimal representation fraction, then you only two possibilities. One is it has terminate digits, okay, or it has repeating digits. Okay, only two possibilities, and infinite digits but repeating. Okay, so for example, like 1/5, right, and it's going to be 0.2. That's with terminate digits, and 1/3 will be 0.3333. Okay, but 1/7, if you do the computation, you are going to get, okay, if you do by yourself, okay, divide by 1 divided by 7, and you get 0.142827. It's not stopping yet, right? Then you find out it's repeating 142857, 142857, and keep it going. Okay. So those are the digits will be repeated. How many of them there are? 6. Okay. So the 11th digit. Okay. What is the 11th digit? Okay. The 11th digit. Okay. The 11th digit is 3 groups here is already 2 groups is already 12, right? So 11th digit will be the 12th digit will be 7. Okay, 11th digit will be 5. Now, what is the 44th digit? Okay, the 44th digit, you have the 44 divided by 6. Okay, it's hard to figure to direct. Okay, 44 divided by 6. Okay, so it's going to be 42. Then have addition 2. So that means you can have 7 blocks of 6 digits plus 2. So plus 2, that will be 4. Okay, because the second digit in the group is going to be 4. So then the sum will be going to be, because why I have to ask the sum? The sum, because I just need one number in the answer. Okay, not just that I want to test you whether you can do addition or not. Just because the multiple choice problem, it's not multiple choice, that in the answer, it's easy for them to grade. Okay, actually, I really want to know how to find the 100th digit, 89th digit, and so on. Okay, so this is just one problem. Okay, my question is, what kind of fraction has terminating decimal point. Okay, what kind of fraction has terminating decimal point? So let's look at the 1 over n. Okay, 1 over n could be 1, can be 2, 3, 4, 5, 6, 7. Okay, so the question, this one has a terminating decimal, terminating digits, right? And if and only if this can be written as something, stop here, we don't know how many. If and only if n is in the form 2 to the p and 5 to the q, okay? It cannot contain as an factors. If it contains factor of 7 or other prime numbers, and you get the infinite many digits in this decimal representation of the number. Okay, for example, 1 over, right? 1 over 10 is going to be 1 over 2 times 5, so it's going to be 0.1. It has only 1 digit after that, right? And then 1 over 5, right, is going to be 0.2. Okay, but as long as you have as long as it contains factor of 3 or 7, some other numbers, for example 15, 1 over 15, you will see that immediately it's going to be 0.0666. Okay, yeah. So it have an infinite many but repeating digits. Sometimes repeating digits will be, it's sometimes just repeating 2 digits, sometimes repeating 3 digits. 1 over 7 is special. It have a 6 digits, right? One block, it has 6 digits. It's repeating. Okay. So let's look at 1 over 4, 1 over 3, 1 over 3, let's list all of them. 1 over 3 is going to be 0.3333, right? The next one is already 1 over 7, really. 1 over 7, we already got it, right? 1 over 7, and this is a surprise, 142,857. This is a 142,857. Okay, and let's look at the next one. 1 over I'm not going to use the prime number. Okay, 1 over the next prime number is going to be 11. Okay, so 1 over 11, it's going to be 0.090909. It's also interesting. You see, repeating, all the digits is repeating. Then 1 over 13, it's going to be 0.076923. Oh, it's not repeating, right? But then you find out 0.76923. So this is a group of 6 digits repeating. Okay? Yeah. So remember, only when contains, only the denominator contains 2, factor 2 and 5, then you have a terminating digits in the decimal representation of the fraction. Okay? Yeah. Only, you see, only in these cases. Yeah. All right. This is about decimal representation of a number. Okay. So can you, what you can find out, this is a block 6, right? So you can, if I ask you to find the 79th digit in the representation, okay, then you just need to 79 divided by 6, and you can figure it out. Okay, so our next problem is record the formula. Record the formula. If you have 1 plus 2 plus 3 plus 4 all the way to n, and this is going to be n times n plus 1 divided by 2. So everybody knows that. No problem. Okay. And in a way it shows up, sometimes it shows up in the following picture. You know, if you have, like if you put the oranges in the picture, like 1, 2, then you have 1, 2, 3, so increasing every time by 1. And then if it has how many layers, suppose you have 9 layers, how many circles in there, right? So, yeah. Okay, so every time you increase it by 1, if you know there are, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If there are 13, circles, okay, how many circles total? Then the total number is, because it's going to be, the total number of the circles will be 1 plus 2 plus 3, because every time, right? And plus 13. You can use our formula to calculate quickly. Okay, so it's going to 13 times 14 divided by 2. Okay, then that is answer, right? N plus n times 1. Okay, n times n plus 1 divided by 2. So as long as you see it's increased by 1 each row, then you know the last row how many of circles there. Then you can using that formula to find the total number of circles. Right. So this is hi. Then my next question is okay. What is the sum of the first? Okay. What is the sum of the first 39 other positive integers? Okay. Right. So how do you do that? What do you mean the 39? 39 itself is other number, but the 39th other integer is not going to be 39. Okay. So we needed to know how to number the other numbers. Other numbers like this. This is the first other number. That's the second one. That's the third one. Okay. And that is the fourth one. The fourth one, 7. Okay. But it's harder to write down the last one. Here, the 39th. What is the 39th? 39th other number. 39th other integer. What is that, right? Okay, so that's my question. So other numbers can be expressed in the form 2k minus 1. Okay, k could be from 1, 2, 3. Okay, so when you change the k, when you change the value for the k, then you get different other numbers. So the first one can be written as 1 times 1 minus 1, right? The second one is 3 is going to be 2 times 2 minus 1. The third one is 2 times 3 minus 1, right? The number 7 is 2 times 4 minus 1. Okay, so every other numbers can be expressed in that form. And then the last one will be 2 times 39 minus 1, because that's a 39th other number. Okay, so if you add them together, you get perfect square. Okay. Right, so you add them together as a sum. If you express other numbers in this form, then you can, you know, yeah, let's rewrite this again. Then you can easily add all the numbers together, regroup them. Okay, I only put then minus 1, minus 1, minus 1. Okay, so regroup them. then you can easily add the first row together, all the number in the first row. But every number in the first row has a factor of 2. So you take 2 out, it's 1 plus 2 plus 3 all the way to 39. Okay? And then you minus how many ones, negative ones? 39 ones. So 39. All right? Then you apply formula, then you can easily add those numbers, 1 plus 2 plus 3, right, add together. So you will get 39 times 40 divided by 2. Right? So now you cancel 2. Now the question is, how can you simplify 39 times 40 minus 39? You shouldn't multiply this out to do subtraction. 39 times 40, then minus 39. No, we take 39 out. You get 40 minus 1. Okay, 40 minus 1 is 39. So 39, 39, 39 square, that's a perfect square, right? So the key point here in this problem is, first of all, you should learn how to add all the integers together, increase by 1 each time. Or there's another point is how to express other numbers. Okay, other numbers can be written in the form 2k minus 1. All right, so the next problem will be, what is the greatest 5-digit multiple of 5 with 5 distinct odd digits? Okay. Now, when you see a problem like that, the greatest 5-digit, okay? So greatest 5-digit numbers. So you have to, but it's multiple of a 5. So use that condition. Don't, forget the 5 distinct 5 other digits right now, okay? So you have to begin with the largest number, okay? So it's going to be, it's, first of all, don't consider last condition. So 990, let's look, 990, 9,990, sorry, 5-digit, okay? So we still have, 99,995. This is a begin with it, okay? But the next one will be, because they're multiple of 5, right? And now, but you have to apply the last condition. Okay, you have to apply the last condition. They are distinct other digits. Distinct other digits. This is impossible, right? So write down the other digits. Okay, other digits. Distinct other digits. So other digits will be 1, 3, 5, 7, 9. Right? Those are the 5 other digits. So your 5-digit number have 5 distinct other digits. That means your number must be a permutation of those 5 digits. And you have to make it as large as possible. Okay? Of course, you begin with 9 and 5, right? But then begin with 9, 7, because 5 is already have to be at the end. Yeah, then 7, 3. Okay, so this is the only choice. Okay, first of all, you have to put 5 at the end. Then you begin with the largest, okay, digits. Okay, then you only have 1, 3, 7, 9 left. So you begin with 7, 9, then 7, then 3, and 1. This is how they get. Okay? Yeah. Similar problems will be similar problem is what is greatest 3-digit integer, okay, with distinct digits, just distinct digits, okay?
187.
Yeah. So you have to begin with, you begin, 999 is not, right? So then the next one, 998 is not, so 997. But if I assume it's multiple, if it's divisible by 3, okay, then yeah, if no other condition, yeah, it's 980, right? 7. Yeah, because you have to choose the largest possible digits, and they are all 3 are different than 9, 8, 7. All right, so my next question is, we have to understand what is the least common multiples and what is the greatest common fact. So here's a question. What is the sum of the greatest common fact and least common multiple of the set? 1, 2, 3, 4, and 5. Okay. I think the greatest common fact is it has to be common fact. But 1, 2, 3, 4, 5. The common fact is going to be 1, right? One is always a fact. Okay. The common factor is 1. Now, what is the least common multiple? And this is also the greatest common factor, okay? If you have 1, right? And then the least common multiple, right? What is the least common multiple? Yeah. So least common multiple is the number which is divisible by all those numbers. So this should be equal to 4. 3 times 4 times 5, which is going to be 60. Okay? So the sum is going to be add them together. Okay? So the sum is 61. Okay? Because we are talking about the sum of the greatest common fact and the least common multiple. Okay? Okay, so that's the sum is going to be 1 plus 60, which is 61. Okay. Now let's do a similar problem about that. Okay. Find the least possible integer, okay? This integer is going to be, has the following property, with the following property, right? Okay, the remainder is always 2 when it is divided by each of the following number. Okay, each of the integer, which is going to be 3, okay, 4, 5, 6, 7. Okay, so I'm looking for the least positive integer. Then that integer must be greater than 2, okay? Otherwise, doesn't make sense. Just 2 is the least, okay? So greater than 2 with the following properties. The remainder is always 2 when it is divided by each of the integers. Okay. Now, how do we understand this type of problem? A number is divisible by, when it's divided by p, right? So you have a p, and that's a quotient. The remainder is going to be 2, right? So this is a remainder, PQR, right? So this is a p divided by, yeah, p is going to be 3, 4, 5, 6, 7. So any of this, right? So when you, and when the number divided by p, yeah, I'm going to rewrite the general formula, okay? Okay. If n is divided by p, okay? If n is divided by p and there was remainder, and then you get remainder r and the quotient q, okay? Then n, first of all, divided by p, right? It's going to be the quotient. The remainder is still there, so r over p. Then if you multiply both sides by p, you get pq plus r, okay? Now this means, okay, be careful. This means n minus r is going to be pq, which is divisible by p, okay? N itself is not necessarily divided by p, otherwise the remainder is going to be 0. But subtract the remainder from the number, and then it must be divisible by p. So in other words, our number, okay, minus 2 is divisible by our number divided by 3, each of the numbers. Okay, 3, 4, 5, 6, 7. Okay. So that's easy mathematics, right? You subtract the remainder from the integer, unknown integer, and this should be divisible by each of these integers. Okay, actually we are looking for the least common multiple of 3, 4, 5, 6, 7. Okay, so n minus 2 is the least common. Yeah, this is not the least common factor. Okay, the least common factor. Okay, you see that 6 contains 6 is 2 times 3, right? And the 4 is here, so it's actually 4, 5, and 3, and 7. This is the least common factor. Okay, right? So this number is divided by 6, divided by 3, divided by 4, divided by 5, divided by 6, and divided by 7. Okay, so you multiply this up, then you will get the answer. Okay, 4 times 5 times 3 times 7. Yeah, it's going to be 420. So n should be called 422. So this is the list possible integers with the property. When it's divided by each of these integers, the remainder is 2. Yeah, but the answer will be 422 because, yeah, otherwise, yeah, you don't get a remainder. All right. So now the next question, it is going to be, we know that the product of 3 consecutive odd integers, okay, is 315. Okay. What is the list of the integers? Okay. So I give you a minute to work on this problem. It's a product of 3 consecutive odd integers. Consecutive odd integers means like, for example, 7, 9, 11. Okay. Hmm? 315. Alex Chen says 105. We're talking about the list of the integers. Okay. So the product of the 3 consecutive odd numbers. Now, how do you express other numbers? Okay, other numbers, 3 consecutive odd numbers, right? But the way we do it is we do the opposite way. We factor 315. We factor 315. It's divisible. You see how to do that, right? It's divided by 5, so 315. You know, use the case 315 divided by 5. You know, this can be 63. Okay, then you continue, factor it, right? 63 divided by 60, you know, 7 times 9, right? We already know that. 7 times 9. Okay, so clearly you quickly get the product of the 5, right? So this is actually the product of 3 consecutive other integers. The list of the integers is going to be 5. I don't know how to get 103. Kevin is right.
Kevin Zane, wait.
Yeah. So the answer is 5. Right. So we're always talking about product of 3 consecutive odd integers. Okay, 3 consecutive odd integers, 3 consecutive integers. Who can explain to me why the product of three consecutive integers is going to be divisible by 6? Okay. Show that the product of three consecutive positive integers is always divisible by 6. Okay. All right. So who can give a argument to show why it's divisible by 6? Explanation.
And he ended up in a nurse. He actually broke his leg.
No. 1, 2, 3.
Yeah, example is okay. 1, 2, 3 is 6. Okay, 2, 3, 4 is gonna be 24, also divisible by 6. Okay, 3, 4, 5, right? It's gonna be 60. It's also divisible by 6. But that's not the proof. That's just examples. Support the claim.
It's 720.
Okay, but we should learn something about the proof. Okay. Okay, so this is the way we had to do it. We David. Okay, so here's the argument. We express consecutive integers into blocks of 3 integers. So we can write in the following way. In the if the 0 is a 3 times 0 is going to be 3 times 0, right? 1 is 3 times 0 plus 1. 2 is 3 times 0 plus 2. Then next one is 3 times 1, right? So in general, you will see that 4 is going to be 3 times 1 plus 1. So you can have a group of 3 integers, consecutive integers, and there the general one is going to be 3k, okay? Then 3k plus 1, 3k plus 2. Okay. So first thing you have to claim is the product of 3. If you can see that, right? The one before that will be 3k minus 1, right? So you can say 3k minus 1 plus 2, 3k minus 1 plus 1, and 3k minus 1. So when you pick up 3 integers, okay, you can either pick up this 3, you can pick up this 3, you can pick up this 3. No matter which 3 you pick up, and it always contains factor of 3. Okay, so the product of 3 consecutive integers always, okay, always contains a factor of 3, okay? But then, okay, then you say divide by 6, because this is the product of 3 consecutive integers, okay? But then always there was 2 consecutive integers. The product of 2 consecutive integers always contains factor 2. Okay, that is the reason it is also contains a factor 2, because the product of 2 consecutive integers always contain a factor of 2. Okay, so why? Because 2 consecutive integers, one is odd even, other one must be odd. As one is odd, other one must be even. 2 consecutive integers always contains a factor of 2. So therefore, of course, the product of 3 consecutive integers, of course, there's a 2 consecutive integers there. So that's what the reason it must contain a factor 2 and 3. That's why it's divided by 6. Okay.
Was the model.
All right, so our next question, it's also related. So the product, stop. The product of 3 consecutive positive integers is, we know that is divisible by now 6 factorial. Okay. What is the least possible average of the 3 numbers? Hmm?
1, 2, 3. 1, 2, 3. 1, 2, 3 words.
Anyone have answers? Only 2? Are you kidding? 3.
It's 1, 2, 3.
All right, Kevin says to, Lou says to, Alex Chen says to, do you think clearly it's 2 or not? So least possible average is, it cannot be 2, come on. Okay, so you have a consecutive integers, 3, n minus 1, n plus 1, right? So the average is actually, average of the 3 numbers is actually the n, the one in the middle, right? Add them together, divide by 3. So if you say it's 2, then just backwards. Then you get, if n is 2, then 1, 2, 3. But 1, 2, 3 is not divisible by 6 factorial. Come on. I'm talking about 6 factorial. 6 factorial is going to be 1 times 2 times 3 times 4 times 5 times 6. Not 3 factorial.
No room to die.
All right, so James Young says 9. Okay, so this is it's divisible by 6 factorial. Okay, so divisible by 6 factorial. So look at this 6 factorial, right? It's going to be 4. It's 2. How many 2's there? 1, 2, 2 squared, 2. So actually 6 is 2 times 3, right? So 2 to the 4th power and 3 squared, then 5. Okay, so this the product of 3 consecutive integers. You know, 3 consecutive integers, we already said that it must be divided by 6. Okay. Right? It must be divided by 6. But now it must be divided by 9 here, right? And by 5. So by simple observation, right? And you can express like 2 cubed, 3 squared, and 2 times 5. And then you find out this is just 8, 9, 10. Come on, right? This is product of 3 consecutive integers.
720.
Yeah, that's so smallest n must be n must be equal to 9. Right? So we find an answer already. Okay, so this is the 6 factorial itself is just equal to product of 3 consecutive integers. Okay. Right, so our next problem is about if so we have a 2 let's see, we have a two integers, two positive integers, okay? N, M, two positive integers, okay? And we know that if the product is 17, what is the sum?
10.5. Isn't it possible? 17 is a prime number.
You're a prime number.
It's a prime number. There is no. There is no sum. 17 is a prime number.
Okay, so
18.
that's right. 17 is prime number. Come on, right? You cannot uniquely determine that if n, m are not integers. So n times m is 17, right? But 17 is prime number. That's right. You notice that. So 17 is prime number. The only possible solution would be n equals 1, m equals 17, or vice versa. But then the sum is going to be 18. Okay. Right? All right. Yeah, I think this is all the problems we have here. And then let me ask you to do another problem. Let's see if you still remember. Okay, here's a question. Find the sum of all integers. Be careful, it's not necessary, okay? And satisfies the following inequality: n over 2 minus 3 less than 7. All right, so the absolute value, do you understand what does absolute value mean,
Yes.
right?
Absolute value is always positive.
Okay, it's always positive. All right, so so for this problem, you cannot by guessing try what number can be less than, for example, n could be 0, okay? N could be 0.
Less than 7 more.
N could be 0, right? So to solve this problem, you have to solve the inequality. And we did this same problem before. It's called solving inequality. So if something is less than, absolute value less than 7, then this number is always between -7 and +7. Okay? The best way to solve the problem, you can add 3 to the both sides. So you get add 3, you can add 3 to 3. So you get -4 less than n over 2 less than 10. Then you divide and multiply by 2 on both sides. It's going to be -8 less than 20. So how many integers there? N is going to be -7. Be careful, -6, -5, and so on, right? And then it's going to be like 18, 19. This is the largest integer. Okay, so you have to divide by. Then you add them together. Okay, I'm asking to just find the sum, not the average. Okay, so when you add them together, how do you do that quickly? I think the sum is going to be, if we add them together, right, this negative numbers, positive numbers that cancel out, 6 plus 7. So you just needed to start with 8 all the way to 19. So those will be canceled out by the symmetry, right? The negative 7 have positive 7 there. So actually it's just 8 plus 9 plus 10 all the way to 19. Now, how to add those numbers together? Okay, first of all, how many numbers there? How many numbers there? How many numbers there? 12. There are 12 numbers there. Okay, 12 integers there. Yeah. So in order to find the sum, so you can use the same trick. The reason I have to figure out how many is because I need that. It's from 8 and 9 and so on. This is 18. This is 19. Right? Double it. If you double it, every number you have here, this is going to be 27, right? And this also 27. And then so on, 27. Here's 27. So total will be 27 times 12. But this is going to be 27 times 12. You have to divide by 2. Right? Okay, so that is answer. Okay, so 27 times 6. Yeah, it's 162. Okay, so that is the sum. Okay, here next problem is a trick. Okay, what is the product of all integers and satisfying the following equality? And that is going to be n over 102 minus, okay, 3, 4, 5, 6, 2 less than 3, 4, 5, 3, 4, 1. Okay. Yeah, look at this problem. What is the best way to do? Joshua?
Yes. Any number.
Yeah, anyone can give me the answers? There's so many integers there.
Kevin.
No?
No, it's not. It's divided by 102. Multiply both sides by 102. So n minus 3, 4, 5, 1, 2.
This is a tricky problem. I told you it's a tricky problem. All right. The answer is 0. The product of many integers, as long as there is a 1 0 there, right? The product with 0, because 0 kills all the right products. If the fact, whether fact is 0, right? Got it. So 0, because 0 is a solution. 0 is a solution because you have to make a simple observation. Okay? It's going to be 3, 4, 5, 1, 3, right? So 0 is a solution. Then no matter how many integers there are, that product will be 0 because any number times 0. Any number times 0 is going to be 0. Good. Okay, so I'm going to send you a homework late. Okay, make sure those who are online doing the homework. Okay,